is
Cristian Zaharia, student.
Hey, Cristian Zaharia, student.
Yes, thank you.
Profesor Mihai Muro, Dr. Cosmin Sinescu, Dr. Florin Budenciu, Dr. Florin Topală, Roxana Romanu, Cristian Zaharia și profesor Podoreanu are the authors for this presentation.
Present, dear guests, doctors and students. My name is Cristian Zaharia. I'm a student in Victor Babeș University of Medicine and Pharmacy in Timișoara. And in the next minutes I will present you the study named Zirconia Field Adhesive for Optical Coherence Tomography Investigations, a qualitative study. When a carrier occurs, a filling is placed in the tooth. A marginal fitting is our concern because sometimes the micro leakage can be found and that will lead to secondary cavity and to the failure of the dental treatment. There are many possibilities for the micro leakage investigation, such as polarized light microscopy, as this paper presented in Brazilian oral research. Another possibility of investigations of the dental fillings is optical coherence tomography. Here we have a part of the results obtained by the Tokyo group, Tokyo Medical and Dental University. Those are a part of the members from the Tokyo group interested in OCT application and development. For this investigation, they used a swept source OCT. This is the design of the swept source OCT system that they use in their study. The wavelength of this source is 1,300 nanometers. Axial resolution is less than 12 microns, and the lateral resolution is less than 37 microns. The aspect of the OCT investigations of the flowable composite filling before and between polymerizations. A gap, here it is, was formed under the composite resin filling, could be spotted in those investigations. The aspect of the gap. This picture is made after polymerization. Our research group has also some papers on this topic. Here we have a C-scan of the filling with bad marginal fitting. This is the same sample, but captured with the B-scan. It's showing the space between the dental structure and the fillings. Our research group did a lot of investigation in this topic, showing problems of marginal fitting on the resin composite fillings, such in this picture, are 0.78 millimeters inside the structure, along with materials defects inside of the fillings. This image presents a poor marginal fitting of the filling together with a defect near. The possibility of this failure is greater in this case due to the defect situation. The main problem in this area of the adhesive layer is hard to say where is the adhesive, where is the air, or where is the adhesive and layer inclusions. The purpose of this study is to investigate through optical coherence tomography an improved adhesive that can be used in imagistic investigations. Materials and methods. First, standardized mesial class 2 cavities were prepared in extracted human teeth. The adhesive used for those samples was filled with zirconia in 3 different concentrations. 4 groups of samples was obtained. Group 1 with 3 samples as standard. Group 2, 3 and 4 with increasing concentration of zirconia. After the application and light curing of the adhesive, the cavities were filled with composite resin from care. The interfaces were examined by optical coherence tomography, OCT, combined with confocal microscopy. The optical configuration uses 2 single-mode directional couplers with superluminescent diode as source as 1300 nanometers. The scanning procedure is similar to that used in any confocal microscope, where the fast scan is unphased line rate and the depth scanning is much slower at the frame rate. Gaps at the interfaces and inside the composite resin were identified as well. This is the aspect of time domain OCT combined by confocal microscopy used for those investigations. The confocal microscopy was used as pilot tool in order to better orientation on the probe. Once the interface between the filling and the dental structure was reached, the OCT was used to explore in depth. On the samples made with normal adhesive, the interface between composite resin filling and the dental structure is hard to evaluate. Another sample with normal adhesive, in which it is hard to observe the adhesive layer and possible aeric defects. Sample from group 1, in which the adhesive layer was modified with zirconia in a layer. 8% of zirconia concentration was added. The adhesive layer seems to be much easier to evaluate. Good contrast obtained between the dental structure, adhesive layer, and composite resin filling after modified adhesive was used. Aeric inclusions into modified adhesive layer. Now these differentiations can be made much easy. Good interfaces between the cavity wall, adhesive layer, and resin composite filling. And in the group 2, the adhesive was modified by adding 2% of zirconia. The interfaces between the dental structure, adhesive layer, and resin composite filling seems to be much easy to detect. Good interfaces with no aeric inclusions between the cavity walls, modified adhesive layer, and composite filling. This is the aspect of the interfaces on swept source OCT after the adhesive was modified, but with 8% zirconia. The aspect of the interfaces on swept source OCT after the adhesive was modified with 2% zirconia. The contrast is increased. And in the end, the aspect of the interfaces on swept source OCT after the adhesive was modified with 3% zirconia. The contrast is even better. In conclusions, the layers of zirconia filled adhesive appear distinctively on optical coherence tomography images, thus providing the possibility to differentiate them from unfilled adhesive, air inclusions, and composite resin. The use of zirconia as an adhesive filler leads to the improvement of bonding layer scattering, thus resulting in an advancement of optical coherence tomography investigating the interfaces of composite resin fields. Thank you very much.
Thank you for a nice presentation. You said you are a student?
Yes.
Congratulations.
Thank you.
So my question is not bad, just only to know. Do you know the dimension of the zirconia particles?
Yes, 10 microns.
All the three?
Yes, 10 microns.
Okay, thank you.